So, we're doing this unit in an odd sort of way, right? I've said that, but this seems the most logical order to me. So we're back to 4C, and today this explanation will cover 4C, and we're only doing 2 questions from it, and then you can move into 4G as well. This flows straight on to exercise 4G. So what we have here is what we call the fundamental theorem of calculus. So you might remember we started 4A doing area calculations, but we were doing approximate area calculations using rectangles, right? What we're doing today is we're looking at how can we use integration to solve it. And so what the fundamental theorem of calculus says is if we have some function and we're concerned with the area under this curve between over the interval A and B, then the area is given by the integral from A to B of the function. Alright, so I've written the first one out for you, but I'm going to show you, I'm going to take you through it, so I recommend you just have a look up here how we solve this problem. It says find the area under the curve, x to the power of 3, from x is 1 to x is 3. So you can see that's the statement written there, right? From x is 1 to x is 3, that's the function. So the way we perform this, alright, maybe I can just follow along each respective step, okay? If we integrate x to the 3, we get the function x to the 4 on top of 4. Now, we won't put plus c in, and we won't put plus c in because this is what we call a definite integral. It's a definite integral because it has boundaries, it has numbers here. Remember, in the previous circumstances, we've just been doing things like this, all right? There's no numbers written here. This is an indefinite integral, all right? So we have definite, it's got boundaries, indefinite, it doesn't. And so when we have boundaries, we don't need to put plus c, and I'll show you why in a moment. All right. So if this is the function, we integrate it, we obtain this big function, right? Capital F of x, and that's what we would differentiate in order to get this one. And the boundaries are from 1 to 3. Okay. So you can see we've moved from this location to here. All right. And then in the next step, we have it's the big function with the top boundary substituted in. So that would be 3 to the 4 on top of 4. Take away the function with the lower boundary submitted in. Substituted in 3 to the power of 4, 1 to the power of 4. Alright, so hopefully you can see that. Here we have A and B, here we have 1 and 3. Here we have f of b, here we have f of 3. Okay, we're substituting 3 in. And then here we have f of 1. And then you're just evaluating that. Alright, so in terms of what's required for a test situation, alright, it'll say something like find the area under the curve using the fundamental theorem of calculus. You need a statement, the integral statement, the substitution, and then here is your answer. Alright, so, and like I've shown you how they've evaluated it, I've done it over successive steps. You can do that if you want, but you don't get any extra marks there for showing the working out. Alright, that's 81 on 4, take away 1 on 4 is 80 on 4, 80 divided by 4 is 20. So all of that, yeah, that's the fundamental theorem of calculus. So let's take you through the next example together then. We have find the area under the curve y equals 3x plus 2 from 0 to 5. So our integral from 0 to 5 of the function 3x plus 2 with regards to x. Okay, that's our first statement, right? We state the boundary, and then we have the function that we want the area under the curve for, dx, because we're performing it with regards to x. Okay, in the next step we're going to have the integral, the integrated function. So when I integrate x, that becomes x squared on 2, right? And then I've got this 3 hanging out the front. So we've got 3x squared on 2. That's what that first one goes to. And then we have plus 2x. And we're going from 0 to 5. Alright. Okay, then in the next step, alright, I'm going to write it out like this. We have f of b, so I'm substituting in 5. So we're going to have 3 times 5 squared on 2 plus 2 times 5. Alright, so that's me substituting in 5. take away when I substitute in 0. Now looking along here, if I put 0 in, that whole thing is going to 0, right? 3 times 0 plus 2 times 0, that whole thing is going to be 0, so I can just put 0 in. Okay, now here's probably a good place for me to point out why we don't need plus c, right? If I put plus c here, okay, at the end here we'll have plus c, and over here we'll have plus c, and we've got c, take away c, it'll just cancel. Alright, so the constant gets rid of itself, and so it's not required when we have a definite integral. Okay? If there's a boundary, we don't need plus c. Alright, so then we've got the takeaway 0, and then we're just interested in what's the answer. Okay? Now, these will get much longer and much more complex. Alright? And so you can fiddle around with this if you want to, but it's not an efficient way of doing it. The fastest way is going to be to put this statement in your calculator. So I'm going to show you how we do that now. So let's pull our calculators out. I'm going to show you 2 strategies for it. Okay, so the first one is just in run math. And what we do is we go option, calc, and you can see integral dx button there. And you just type in everything exactly as we've got it. We want the integral of 3x plus 2 over the boundary 0 to 5, and we evaluate it. I've got 95 on 2. It's at 47.5. Now, there's 2 circumstances in which you get asked definite integrals. The first is when it says find the area. So if it says find the area, then you need units squared, right? It's some area, and so we need to tack that unit squared on it. Sometimes it will say find the value of this definite integral. And in that circumstance, it hasn't prescribed that you're finding an area, it's just said you're finding the value of a definite integral, in which case you don't need the unit squared. Okay, so just 2 sort of technical properties that will pop up throughout the exercise. Okay, option cap, put all that in, that's what you get. That's the first way of doing it. The second way is, let's go to our graph, and let's graph this function we're interested in, right? 3x plus 2, we've got a domain over which we're interested in it. We're interested in it from 0 to 5. Let's graph it though. Let's graph it from -2 to 7, just so we can see it more clearly. From -2 to 7, and then set y appropriately. So I'm setting y from 0 to 20. Alright, so I've graphed this function, and I'll put the v window up that I've got here, my v window. I set my x min as -2, x max as +7, y min is 0, y max as 20. Alright, and that's a pretty good window to have a look at it. Alright, so everyone should look like mine, right? It's the equation of a line. Okay, and then we press G solve. We press the across arrow to bring up the further options, and we can see there's an integral button there. Okay, area under the curve, we press that one. It's going to pop up with a number of different options. For our purposes, for now, we're just clicking on the first one, the integral of dx, and then we need to type in the lower boundary. So I'm going to press 0, and my upper boundary 5. It's going to shade that area, and it's going to tell me the value of it as well. So your calculator's going to colour it in for you. It is very sweet. You'll be able to create some beautiful artwork there, get different colours happening. So, alright, so that's how we use our calculator. But the point is to say when we're applying the fundamental theorem of calculus, right, at this step I could have gone, yep, that's 3 times 25 divided by 2 plus 2 times 5, and I can keep evaluating. But that's not necessary. When we're using the fundamental theorem of calculus, all right, we just go from here straight to our answer, okay? Unless it's like ln and e and it wants the answer in exact form, okay? In which case we're going to have to process it a little bit. All right, so that's question A and B, and this skill here is what you're doing in 4G, all right? There's a little bit of it in 4C. 4C question 4 is this skill, and this skill is in 4G. All right, next let's move on to question 2, which is a proof. All right, so the other part that we're going to do in 4C is a number of proofs. So I'll clear this off. And we've got, using the fundamental theorem of calculus, prove that the integral from A to B of K is equal to K times B take A. Alright, this is what it wants us to prove. And so when we have a proof, what we need to do is we need to show that the left-hand side is equal to the right-hand side at any stage. Alright? So I'm going to start with the left-hand side. Alright? And I'm going to say, this is what it says on the left-hand side, right? This is what we've got. The left-hand side is this statement. Okay? So let's evaluate that, alright? If we have the integral of k is some number, it's not a function. And so if we integrate k, we're going to get kx, right? And what's the interval over which we're integrating? From A to B. Alright, so we can see a link from there to there. I've just moved to the second step. If we integrate k, we get kx, and here's the interval over which we're integrating. Alright, now, if we're going to perform the next step of the fundamental theorem of calculus, we substitute in b, so we have k times b, and then we take away the lower substitution, k times a. Alright, so there's one more thing we can do, but what I want to do is I want to show you a number of ways of doing it, right? And so you might go there and you might go, oh, I can't really see how it's the same. Let's go to the right-hand side. Okay, I've got the right-hand side is equal to k times b take a. Alright, what's another way I could write this? I could expand it, right? I could have it as k times b take away k times a. Oh, look, I've manipulated the left-hand side, I've manipulated the right-hand side, they are the same. The left-hand side is equal to the right-hand side, QED. Alright? So that would be a perfectly fine way of communicating. You've got the left-hand side, you've evaluated it to that, you've got the right-hand side, manipulated it to that, they're the same. Okay? Another way would just be to carry on here, right? At this step, we can factorise k, in which case, if we pull k out front, we've got equals k times b take a, which equals right-hand side. Alright, so you can have that sort of one-way proof, or you can have it two directions. You've got the left-hand side and the right-hand side. Alright, either of those is suitable. And so what you're doing in question 5 of exercise 4C is going through those properties and proving them using this skill. Alright, so this is a really good exercise for proofs. So what we'll start with today, exercise 4C. Question 4 is area calculations, so using the fundamental theorem of calculus. Question 5 is these proofs. That's definitely what we do today, and then you'll transition into 4G. Alright, once you pull the shut off, you'll be well on your way to 4G. So use your calculator to support you, it's there to help you out. That's our plan today.